Hey, good morning, it's Horner. So this is a question where you do have to do some math because they do want to know by what factor certain things are greater or smaller, or how many times higher does it go. So the first thing on this problem is when you have a ball that's thrown at one angle and then another ball or the same ball that's thrown at a different angle, you could actually go through and do all the calculations to figure out if they would land close to each other. And here, when you do the calculations, you find out that they land at the same spot. But there's a trick to this one, and that's why he put it on here. Anytime the two angles add up to 90 degrees, then both of those balls will end up at the same spot. So as long as they're both less than 90 and they add up to 90, then when the red ball is shot out, it doesn't go very high, so it's not in the air for a long time, but it has a bigger velocity in the x direction. So for the ball at the 30-degree angle, we have a velocity in the x direction that's that big. And for the ball that is at 60, that one is only going to be that big. And remember, the bigger the arrow, the faster it's going, and the further it will go, unless they're at different angles. So because the one with the x value that's really big is not in the air for very long, and because this one is in the air for a much longer time, it doesn't have to go as fast to cover that same distance. So in the end, all you have to remember is if the two angles add up to 90, so if you take 90 minus one of the angles and that gives you the other angle, then they both will hit at the same spot. They want to know which ball travels a greater vertical distance. So remember, that's our distance from the very top to the very bottom. And you can kind of see just from this that the ball that is green goes a lot higher than the ball that is red. And they want to know how many times higher. So the thing that we have to figure out is how high do each of the two balls go. So to do that, we have to find the speed in the y direction, which we did right here. So we did 5 sine of 60, and that gives us our speed up. If we use that speed up and we put it into the third kinematics equation, and we know that the speed at the top is 0, because when it goes up, remember, just up, this would be 4.33, and then as it gets to the top, there's no speed in the y direction, because we're only worried about one direction here at the very top, so that's 0. This is 4.33 squared plus 2 times negative 10 times our height, and that ends up being 0.937. Now we have to do the same thing for the 30 degrees, and the 30-degree red one, remember, that vertical arrow is not as big as the one with 60, so we know it's not going to go as high. We're going to use that same equation. We're going to do 5 times the sine of 30 and get 2.5. Plug that in down here and solve for the height. And we see that the height that this one gets to is only 0.3125. So to find that factor, we're going to just divide the two. So 0.937 divided by 0.3125, and you end up with, it goes 3 times higher. And you'll notice this one's the same type of thing. So there's 1, there's 2 heights, and then there's that third, or the 3 times higher than the 30 degrees. They then want to know which ball spends more time in the air, and by what factor is this greater or smaller. So factor and how many times, same thing. So for letter C, I did it down here, and it says they want us to find time. So we know the final velocity is 0. We know the original for this one is 4.33, so we've already done that. And then we have to put in gravity, which is negative 10 times the time, and we find the time to be 0.433 seconds. When we do it for the red ball, we're looking at that speed up again, which we said originally was 2.5, and then we add to that our -10 times time, and we get 0.25 seconds. So to find how many times bigger, or by what factor is it bigger, we just take our 0.433 divided by 0.25, and we see it's in the air 1.73 times longer than the red ball. And that hopefully is helpful. Good luck on your exam today.